All right, everybody, this is section 2.5, zeros of polynomial functions. So the first thing we're going to talk about are rational numbers. So what are rational numbers? I should open up the pen here. So rational numbers are numbers that can be divided by two integers. So numbers that can be divided by two integers. They're also numbers that can be expressed as fractions. So numbers that can be expressed as fractions. So something like, 3/2. So I'll put that at the top. 3/2, 1.5 can be expressed as a fraction. So it's rational. Something like pi is irrational. And the reason is there are no two numbers that you could divide and get pi. So what we're going to do today, the goal for this video is to find all the zeros of polynomials, rational and irrational. And we're actually going to use the rational ones to find the irrational ones. So if you look at the polynomial right here and the graph is on the right, there are three zeros. They're highlighted. X equals -3, -1, and 2. So what we're going to talk about today is what happens when they're not all easy, nice, whole numbers. And we have irrational ones. All right, so we're going to find all the zeros of 15x to the third plus 14x squared minus 3x minus 2. Now, if you look at the graph to the right, that's a little screenshot of this function on Desmos. So if you see there's three zeros at -1, and then the other two are not at whole numbers. So we have to use the zero at -1 to figure out what those other two zeros are because they're not whole numbers, or we don't know if they're rational yet. So the first thing we're going to do is we're going to turn this cubic into a quadratic. And we're going to do that by using synthetic division using the zero that we know. So the zero that we know is x equals -1. So if you remember from last class synthetic, we have to write our coefficients, 15, 14, -3, -2. Draw that little line. First one, we drop the 15. 15 times -1 is -15. 14 minus 15 is -1. -1 times -1 is 1. -3 plus 1 is -2. And -2 times -1 is 2, I'm sorry. And -2 plus 2 is 0. So we know that x equals -1 is a 0 because there is a remainder of 0. So that tells us that x plus 1 is a factor. So we know that's good. So my quadratic is 15x squared minus x minus 2. Now you're going to say to yourself, well, how do I know what the zeros are? Well, now that it's a quadratic, we can either factor or use the quadratic formula. For this one, we're not going to factor it. We're just going to go right to the quadratic formula. So I'll just switch the color so everybody can see it. Let's do this down here. -b plus or minus the square root of b squared minus 4ac all over 2a. So that equals the opposite of -1 plus or minus the square root of -1 squared minus 4 times 15 times -2. That whole thing over 2 times 15. When you simplify that, it becomes 1 plus or minus square root of 121 all over 30. So that gives us 1 plus or minus 11 over 30. So we have two solutions, which is going to be 12 over 30 and negative 10 over 30, which gives us 2/5 and negative 1/3. So those are the other two roots. So that's how you find all the zeros. You use synthetic, get yourself a quadratic, and then solve the quadratic. All right, so these are just some quick steps that we're going to use to continue finding the zeros. So the first step is to just factor if possible. The second step is to graph on Desmos to find a rational zero. So that was what I did on the first slide. Remember how I looked at the little graph to the right? I said, oh, there's a whole number zero at -1, and I used that one. Then we're going to use the rational zeros in synthetic division until the quotient is quadratic. So you have to keep repeating it until it is quadratic using the same zero, and then you can solve the quadratic using the quadratic formula, or you can factor it. All right, here we go. So for some of the questions, they might give you a zero. So you either have to look on the graph using Desmos, or they're going to give you a zero. Here they gave you a zero. So we can go right to our synthetic. So I'm going to put 2 in the little box. 1, 2, -5, -6. And I'm going to do my synthetic division. 1, 2, 4, 8. Then I get a 3, 6, 0. So this is x squared plus 4x plus 3. Again, the remainder is 0. So I look at this one and I'm going to say to myself, I think I could factor it. So I'm going to set it equal to 0. X plus 1, x plus 3. If you are not good at factoring, you can use the quadratic formula, but for some of them, it is a little easy. So this is x plus 1 equals 0. This is x plus 3 equals 0. So here's x equals -1, and x equals -3. So that's a 0, that's a 0, and remember the last 0 is x equals 2 that we used in the beginning. So that is how you find all the zeros. All right, so I want everybody to try this one on their own. So pause the video and find all the zeros. All right, here's what you should have gotten for example 3. Use a synthetic, get the quadratic, factor it, 3 zeros. So that is example 3. All right, now we have example 4. Find all zeros given f of x equals x cubed plus 7x squared plus 11x minus 3. And you see that you're not given any zeros. So what you're going to do is you're going to go into Desmos. I typed the function in just to save some time. You're going to type it in, and you are going to pull the whole number 0. So the whole number 0 here is x equals -3. So we're going to get it from Desmos if 1 is not given. And now from here, we're going to do what we were doing before with -3. So we're going to use -3 as our 0. And again, we got that from Desmos. And now you're going to, do the problem like we've been doing. So 1, 7, 11, -3. Draw the bar. 1, -3, 4, -12, -1, 3, 0. X squared plus 4x minus 1 equals 0. And we're going to have to do the quadratic formula for this. All right, so here is the work after the quadratic formula. You get -4 plus or minus the square root of 20 over 2. We break down the square root of 20 into 2 root 5. We got that from doing square root 4, square root 5. Simplifying -2 plus or minus root 5. And you put that in the calculator and you get two roots. 0.236 and -4.24. And if you look back on the Desmos, those are the same ones here. -3, the one we used, and the other two that I rounded off on the previous slide. So that is how you find the zeros when you are not given one and using Desmos to get one. All right, the next one we're going to do, this one's a little different because it is x to the fourth minus 6x squared minus 8x plus 24. So if you go to Desmos and type this in, you should get a whole number root of x equals 2. Let's just check that real quick. All right, so when you look at Desmos, you're going to notice that there is only one real root there, but we're going to keep going, and it'll make more sense as we get to the end. So we check Desmos. We're going to use 2. We're going to see what's going on with the other ones. So we're going to put 2 in the little box. 1. Remember, we need a placeholder for the cubic term. 0, -6, -8, 24. 1, 2, 2, 4. You guys should be getting kind of good at this by now. So this is x cubed plus 2x squared minus 2x minus 12. Now notice that this is not a quadratic. So we're not ready to solve. We have to do synthetic again using that same 0. So now it's going to be 2. And now I'm going to use these coefficients. So 1, 2, -2, and -12. So again, 1, 2, -2, -12. 1, 2, 4, -8. Oops, I'm sorry, hold on. Sorry, this should be +8. Sorry. So 4, 8, 6, 12, 0. So now we have x squared plus 4x plus 6 equals 0. So now we have a quadratic. Now we can solve the quadratic. So we're going to have to use the quadratic formula. X squared plus 4x plus 6 -4 plus or minus the square root of -4 squared minus 4 times 1 times 6 all over 2 times 1. So that is going to give me -4 plus or minus the square root. And now you should notice something weird when you do under the square root. You should get 16 minus 24, which is -8 over 2. So now you should say to yourself, I have a negative under the square root. What do I do? And imaginary numbers should come into your mind. Where now you're going to have -4 plus or minus I root 8 over 2. We keep simplifying. -4 plus or minus 2I root 2 over 2, which simplifies -2 plus or minus I root 2. And those are your imaginary zeros. So sometimes we're going to have imaginary zeros. So really, we had to do synthetic division twice because we started off to the power of 4, got down to a cubic. We need to do it again, make it quadratic, use the quadratic formula. We have imaginary roots. Now remember, if we go back to Desmos, this was the 0 we were talking about right here at x equals 2. Remember, that means since we have to use it twice, there was an even multiplicity at that 0. And you can even tell that it was an even multiplicity because if you look at what happens at the x-axis, we have a touch and a turn. So we have x equals 2 is our rational root. Over here, we found the irrational ones, ended up being imaginary roots, -2, plus or minus I root 2. And it makes sense because we used the 0 or the root twice. So I'm going to circle it. We used it there once. We used it there once. That means that there is an even multiplicity on that root, which you can tell from the graph because of the touch and turn. So that's the big example. All right. So now I want let me just clear this out. Get rid of that. I want everybody to pause the video and try to do this one. So go ahead. You're going to have to go to Desmos, get your 0, and then do the whole thing. All right, so this is example 6 worked out. First, we used synthetic to get a cubic. So that is x cubed minus 5x squared plus 17x minus 13. Got that in purple. Then I had to use synthetic again to give me a quadratic. Remember, quadratic is power of 2. X squared minus 4x plus 13. Came over here, used the quadratic formula. And here are my roots down at the bottom. 2 plus or minus 3i. If you go to Desmos, I got the 1 from right here. No other roots. They are no other real roots. They are imaginary. So that is how you do all of the irrational and rational roots. Remember, follow the quick steps here. But that is all for the notes.